examples regarding testing for the radius of convergence and interval of convergence. Let us consider this series with a sub n equal to 5 raised to k x raised to k all over k squared. So to compute for the radius of convergence and interval of convergence, we are going to use ratio test. We are going to determine the interval at which this series would converge. So what is the condition for convergence in a ratio test? Your ρ, which is the limit of your a sub k plus 1 over a sub k as k approach infinity must be less than 1. So a sub k over a sub k plus 1 over a sub k. We want to check the limit of this ratio and check whether it would be approaching a value less than 1. So your a sub k is 5 raised to k, x raised to k over k squared, and your a sub k plus 1 would be 5 raised to k plus 1, x raised to k plus 1 over k plus 1 squared. So this would be the limit as k approach infinity for 5 raised to k plus 1 x raised to k plus 1 all over k plus 1 squared all over 5 raised to k x raised to k over k squared. So your ρ is equal to the limit as k approach infinity for 5 raised to k plus 1 is the same as 5 raised to k times 5. X raised to k plus 1 is x raised to k times x raised to 1 all over k plus 1 squared. We're going to multiply this by the reciprocal of the denominator k squared over 5 raised to k times x raised to k. So we can divide 5 raised to k by 5 raised to k, x raised to k by x raised to k. So we will now be left with ρ equal to the limit as k approach infinity of we will be having 5x k squared over k plus 1 squared. We're going to apply properties of limits so we can factor out the expression without the variable k. And then we can have the limit as k approach infinity for, so there is an operation between this quotient. So we have k over k plus 1 quantity squared. So we can evaluate the limit of the quotient first, and then after which we square the result. So this would be 5x, and then the limit of k plus 1 over the limit of k plus all over k plus 1 is infinity over infinity. So it we can apply L'Hopital's rule. So if we apply L'Hopital's rule, it would just be 1 squared. So we will now be having 5x, and this should be less than 1. So the ratio should be less than 1. So with that, we can divide both sides by by 5 rather, a positive constant. So the positive value of x is less than 1 over 5. So we can now say that the radius is 1 over 5. Take note that the center is located at x equal to 0. So x raised to k, so we equate x to 0. So x is equal to 0 is the center. So for the interval of convergence, we have your x to be in between 0 plus 1 over 5, and we also have 0 minus 1 over 5. Now the question now is, should we include or exclude the endpoints? So what we're going to do is to test at the endpoint. So at x equal to 1 over 5, so when we plug in x equal to 1 over 5, do we have a convergent series or a divergent series? So your a sub k would be 5 raised to k x raised to k over k squared. When x is 1 over 5, it would be 5 raised to k 1 over 5 raised to k over k squared. So this would be 1 over k squared. And this is convergent because it is a p series with p equal to 2, greater than 1. Let's try at x equal to negative 1 over 5. So when x is negative 1 over 5, so your a sub k would be 5 raised to k, negative 1 over 5 raised to k. So that's negative 1 raised to k all over k squared. So this is having a limit of a sub k equal to 0, the first condition, and it must be decreasing. So this is an alternating series because of the presence of negative 1 here. So it is an alternating series that satisfies both condition. The limit of 1 over k squared is approaching 0, and it is decreasing because 1 over 1 squared plus and then 1 over 2 squared, 1 over 4 squared, 1 over 1 over 3 squared, 1 over 4 squared, 1 over 5 squared is decreasing. So therefore, we are going to include 1 over 5 and negative 1 over 5. So the center is at 0. The radius is 1 over 5. And the interval of convergence is inclusive. So negative 1 over 5 to 1 over 5. So your x is 1 over 5, negative 1 over 5 inclusive. Next, let's have our a sub k. What would be our a sub k here? So this would be 3 times x plus 5 all over 4 raised to k. So 3 times x plus 5 all over 4. So I think it is best to use root test for this. For the root test, your RO is the limit as k approach infinity for a sub k, and it should be less than 1. So taking the kth root of anything with raised to k, so your RO would be 3 times x plus 5 all over 4, and the limit as k approach infinity would be less than 1. So of course, you can see that there's no k here. So we're going to just have 3 over 4 times x plus 5. The absolute value of this must be less than 1. It should be positive. So the center is located at x plus 5 equal to 0. So x is negative 5. And if we're going to multiply both sides by 4 over 3, so we have x plus 5 is less than 4 over 3. So the radius of convergence is 4 over 3. For the interval of convergence, it would be x negative 5 plus 4 over 3 and negative 5 minus 4 over 3. So that would be the interval of convergence. Now the question is, should we include the boundary? Should we include these 2 points? So what we're going to do is to solve for the x's. Negative 5, so negative 15 over 3 plus 4 over 3 is negative 11 over 3. Negative 5 over 3 minus 4 over 3, so negative 15 over 3 minus 4 over 3 is negative 19 over 3. So at x is equal to negative 11 over 3, so our series is 3 over 4 raised to k times negative 11 over 3 plus 5 raised to k. So this would be 3 over 4 raised to k times 4 over 3 raised to k. So this is 1 raised to k. So 3 over 3 is 1, 4 over 4 is 1, so we have 1 raised to k. So this would be 1 plus 1 plus 1 plus 1 plus 1 plus 1 and so on. So this would approach infinity, or the sum would approach infinity at x is equal to negative 19 over 3. So we have 3 over 4 raised to k. And then we have negative 19 over 3 plus 5. So 3 over 4 raised to k, negative 4 over 3 raised to k. So this would be negative 1 raised to k. So it would be negative 1 plus 1 minus 1 plus 1 minus 1 plus 1. So this would be either 0 or negative 1. So there's no unique value, so it would be divergent as well. So it would not include both endpoints. So this is divergent here, this is also divergent. So the endpoints would not be included. You can also see that this is a geometric series. So it would be 3 over 4 x plus 5 raised to k. So the first term is a sub 0 equal to 1. And the common ratio is 3 over 4 times x plus 5. In order for it to be convergent, the common ratio should be less than 1. So we have 3 over 4 times x plus 5. So the absolute value is less than 1. So meaning it would be less than 1 and greater than negative 1. We can multiply both sides by the reciprocal. So it is positive number. So you can apply that. Negative 1 times 4 over 3 less than x plus 5 less than 4 over 3. And then we subtract 5 from both sides. So we have negative 5 minus 4 over 3 less than x. And then negative 5 plus 4 over 3. So your x is in between negative 19 over 3 and negative 11 over 3. So that's all for radius and interval of convergence.